Hi Neet Aspirants, welcome to Vari Medical Academy. Vari Medical Academy சார்பாக அனைத்து விதமான டாபிக் சார்ந்த ஒவ்வொரு வீடியோவும் இனி வரும் நாட்களில் உங்களுக்கு வரும். உங்களுக்கு இதை சார்ந்த சந்தேகங்கள் கேள்விகள் எதுவாக இருந்தாலும் கமெண்ட்ஸில் பாஸ் பண்ணுங்கள். எங்கள் எக்ஸ்பர்ட் ஃபேக்கல்ட்டி மெம்பர்ஸ் போடுற வீடியோஸ் பிடிச்சிருந்ததுன்னா ஷேர் பண்ணிக்கோங்க. அந்த வீடியோ ரெகுலராக உங்களுக்கு வரணும்னா சேனலை சப்ஸ்கிரைப் பண்ணிக்கோங்க. தேங்க்யூ. Wish you all the best.
Yes, good afternoon students, and today I am going to explain valence bond theory. If you want my videos on YouTube, please type chemical bonding. It will be Vari Medical Academy. You can search Vari Medical Academy. Chemical bonding, introduction and Lewis dot structure, everything is available. Hybridization. Today VBT, valence bond theory. Right ma? VBT, valence VBT. It will be proposed by Pauling and Slater. VBT is proposed or introduced by Pauling and Slater. These two scientists, before scientists given this theory, but it is drawback is there. And the next scientist, Pauling and Slater, they introduced the valence bond theory. What is valence bond theory means? Atomic orbitals overlapping, atomic orbitals overlapping atomic orbitals overlapping to form covalent bond. And which type of atomic orbitals? That to be same energy atomic orbitals they are overlapping to form covalent bond. The first point is atomic orbitals overlapping to form covalent bond. Next one is atomic orbitals, off-filled atomic orbitals. Who are involved? Off-filled atomic orbitals, off-filled atomic orbitals with opposite spin. They involved in overlapping. Off-filled atomic orbitals with opposite spin. If off-filled means, we can take this is the off-filled orbitals. This is one of the electron above and another one is like this. Means the off-filled atomic orbitals, these are the off-filled orbitals with opposite spin. The opposite spin, this one is this above side, this one is below side. Next one is, next point write down, extent of overlapping must be less than 50%. Overlapping must be less than 50%. That is the rule. What are the rules of VBT? Atomic orbitals are overlapping, not intermixing, not combining, overlapping to form covalent bond. Next one is off-filled atomic orbitals or off-filled orbitals with opposite spin. The electron spin is one is above, one is below, one is clockwise, one is anti-clockwise, like that. Next one is overlapping must be less than 50%. Overlapping must be less than 50%. Write this point. Another point I am writing. Extent of overlapping increases. If I am writing extent of overlapping increases, what is happen? If extent of overlapping increases means bond strength is increases. Bond strength increases. If bond strength increases means bond energy also increases. If bond energy increases means bond length decreases. Remember this one. Extent of overlapping increases, and that is directly proportional to bond strength. When bond strength is increases na, bond energy increases. When bond energy increases, bond length is decreases. Because bond energy means if two atoms very near, more bond energy. For these two atoms are very far away from each other, more bond length. If more bond length means you can break the bond easily, less amount of energy required to break the bond. Next one is overlapping of atomic orbitals. There are two types of overlapping. You know, two types of overlapping. One is axial overlapping, or head to head overlapping. Another one is another same head to head overlapping. Head to head, these two heads overlapping. In head to head means along the internuclear axis, more extent of overlapping. That is the axial overlapping. Axial overlapping, head to head overlapping to form sigma bond. It will be sigma bond because in sigma bond extent of overlapping is more. More extent of overlapping means more strength of the bond. Next one is another one I am writing here, parallel overlapping, or sidewise overlapping, that is the pi bond is formed. This is less extent of overlapping, here is more extent of overlapping. More extent of overlapping sigma bond is formed, that is axial along the internuclear axis. For example, in axial overlapping and s orbital, p orbital, now p orbital and p orbital, they are overlapping to form sigma bond. Which type of orbitals, students? S and s orbital. If overlapping of s orbital, they form sigma bond. For example, this one is a plus one of the s orbital, this is the another s orbital, they are head to head overlapping to form sigma bond. For example, this is a one of the 1s1, here also 1s1, one of the atomic orbital, here is another atomic orbital, they are mixing, here is a sigma bond is formed, s orbital. Next, spp mixing means sigma bond is formed, even pp mixing also sigma bond. Now lateral or sidewise overlapping means like this overlapping. Overlapping will be sidewise of pp orbitals. If p orbital, d orbital, and d orbital, that is a pi bond is formed. Here is p pi, d orbitals are overlapping, that is sidewise overlapping. Here is less extent of overlapping is happening, here is more extent of overlapping is. If more extent of overlapping, more strength of the bond, this is the less strength of the bond. Pi bond is the less strength of the bond. Next one is we have to write sigma bond overlapping. What is the overlapping of sigma and pi bond? But overlapping atomic orbitals are must have same sign. If same sign of orbitals, for example plus, they are plus overlapping means bonding, and plus minus means anti-bonding. That is the overlapping atomic orbitals must have same sign. For example, I am taking here is s orbital, one of the s orbital, plus here also another s orbital, they are not sidewise, head to head overlapping along the internuclear axis. Here is formed sigma bond. Here is formed sigma bond is formed. This is called SS overlapping of orbitals. Next one is one of the s orbital, another one is p orbital, that is plus minus. Here is overlapping atomic orbitals must have same sign. Same sign means plus plus bonding. Write down this. Here is like this bonding. It is formed sigma bond. sp. This one is s orbital. This one is p orbital. Next one is if you take p orbital, p plus, here is minus, here also plus, here is minus. Maybe pz, we can take a sigma bond is formed. Here is this one, lines also like this, you can see minus and minus. And this one is a pp mixing. What is the bond is formed? Sigma bond is formed. Sigma bond is formed. These are the ss overlapping, sp overlapping, and this one is pp overlapping also. Sigma bond is formed. Next one is the, I am taking one of the p orbital. Here is plus minus. Another one also I am taking, this one is py plus, another one also plus minus. Here also py, because lateral overlapping, lateral side overlapping or sidewise overlapping, to form pi bond is formed. Here is extent of overlapping is less. Here is sidewise overlapping means extent of overlapping is less. Here is head to head overlapping means more. Here is pp. Next one is I am taking p orbital, another one p orbital plus minus. Here also plus. Here is I am taking d orbital, one of the d orbital. Here is minus, here is plus. Here is plus, here is minus. They are overlapping. We can write like this. Here is overlapping, here overlapping. Here is this one is the p orbital and this one is the d orbital. This one is the p pi d pi bonding. B pi d pi bonding. This one is example of p pi and p pi bonding. Next, d orbitals are intermixing. Here I am taking. Here is pd mixing, p pi d pi. First one is ss mixing, sigma bond. sp mixing, sigma bond. Even p orbital mixing, sigma bond is formed. Here is py, there is lateral or sidewise overlapping. Sidewise overlapping is less extent of overlapping. Here is p orbital, d orbital, p pi, d pi. If you overlapping of d orbital, write down. Here d orbital plus minus. Here is minus, here is plus. Another d orbital I am taking. Here is 2d orbital. Here also taking plus minus. Here is plus, here is minus. They are overlapping after. This one is overlapping and this one is overlapping. And I am writing like this. This is d pi overlapping. D pi and d pi. Because the d orbital, this is the one of the d orbital, another d orbital, here is formed, pi bond is formed. These are the different types of overlapping. One is axial overlapping, another one is axial overlapping, another one is lateral overlapping or sidewise overlapping. These are the, we can take axial overlapping and sidewise overlapping. Axial overlapping means head to head. This one head, they are head to head overlapping means more extent of overlapping to form sigma bond. Here is s orbital, p orbital, that one also sigma bond is formed. Here also p orbital, that one also sigma bond. These are the axial, and sigma bond gives axial overlapping gives sigma bond, and sidewise overlapping gives pi bond. Next one, we can take the examples. First one is HF. I am taking HF. In this HF, hydrogen and fluorine, the bond is sigma bond. That is, sigma bond is present. Now I am writing hydrogen electronic configuration 1s1. 1s1 means 1 electron is present. Next one is a fluorine electronic configuration. Write down 1s2, 2s2, 2p5, 2p5, because atomic number is 9, 5, 2, 7, 8, 9. Now write last orbit, that is a p subshell. How many? 5 electrons are present. Now 1, 2, 3, and this one is 4. 4 is present. Now here is one of the hydrogen atom. Fluorine is 1s2, 2s2, 2p5. That is total is 9. Now here is pz. Here is this one is s orbital. This one is p orbital. Means 1s and 2p orbitals are overlapping. 1s and this is 2px. This is 2px. This is 2py and 2pz. Now sigma bond is overlapping of atomic orbitals of hydrogen and pz atomic orbital of fluorine to form sigma bond. Now I am taking BF3. If I am taking BF3, in this BF3, boron electronic configuration is 1s2, 2s2, 2p1. Here this is the ground state electronic configuration. Now I am taking first excited state. The first excited state means one of the electron jumped from s orbital to p orbital. Now write 2s1, here is 2s1, here is 2p2. Next one is fluorine electronic configuration. Already 7th group element na. Fluorine is the 7th group. The atomic number is 9. 5 plus 2, 9. Now here how many electrons? 3 electrons. Here is fluorine electronic configuration. This one is 2p5 and last orbit I am writing. Last orbit 1, 2, 3, 4. Here is 5 na. Yeah, 5. Another one also, another fluorine atom. Here is 5. 1, 2, 3, 4, 5. Here is opposite spin. I am writing opposite spin. Off filled orbitals with opposite spin. Another fluorine atom. Here also 1, 2, 3, 4, 5. Here is off filled orbitals with opposite spin. Here is 1s2, 2s2, 2p5 students. 1, 2, 3, 4, 5. One of the off field orbitals with opposite spin. This is the sigma bond is formed. Here is BF3. How many sigma bonds? 3 sigma bonds are present. Now I am writing this one s orbital mixing with this one, and this one is mixing with this one. This one is overlapping with this one. Here is 1s, 2s. This one is 2s. Next one is this one is 2p. Here is 2p. One is 2s, 2p. One is 2s, 2p. Next one is 2p and 2p. Next one is another one also 2p versus 2p. Here is 2pz and 2pz, 2py and 2py. These are the overlapping to give covalent bond. How many sigma bonds are present? Here BF3. How many sigma bonds? 3 sigma bonds. This is the overlapping of atomic orbitals. This is the BF3 and this one is HF. If you taking water H2O, H2O. Oxygen electronic configuration 1s2, 2s2, 2p4. 1s2, 2s2, 2p4. Here is 4 plus 2, 6, 7, 8 electrons. Here I am writing how many? 1, 2, 3, 4. Here is each hydrogen atom 1s1, one of the hydrogen, another hydrogen atom also 1s1. Here also opposite spin, and this one overlapping, and this one overlapping to form H2O. How many sigma bonds are present in H2O? 2 sigma bonds. This one is a hydrogen. Here is hydrogen. Here also hydrogen. 2 lone pairs are present, and these are the 2 sigma bonds are formed. The example of H2O. Overlapping of atomic orbitals to form covalent bond. First I am taking HF. Hydrogen electronic configuration is 1s1. That's why 1. Here is fluorine electronic configuration is 1s2, 2s2, 2p5. And 2p5 means 1, 2, 3, 4, 5. Here atomic orbitals of off-filled. These are the off-filled orbitals with opposite spin. Here is opposite spin. We have to write opposite spin. They are overlapping to form covalent bond. If you taking BF3, in this BF3 boron electronic configuration is 1s2, 2s2, 2p1. Boron atomic number is 5. That's why here is in the ground state is this is electronic configuration. In first excited state, one of the electron jumped from s orbital to p orbital. Now here is 3 electrons are available and 3 fluorine atoms having opposite, means what is the VBT? Off-filled orbitals with opposite spin, they are overlapping to form sigma bond. This is called sigma bond, means axial overlapping. Next, if you take water molecule 1s2, 2s2, 2p4, in this electronic configuration, write 1s2, 2s2, 2p4. Now I am taking out last cell p4 na p4 1 2 3 4. Here is off-filled orbitals with opposite spin, hydrogen and hydrogen atom and 2p. Here is overlapping to form 2 sigma bonds. This is the axial overlapping or internuclear. Axial overlapping, internuclear, axial overlapping. Sigma bond is formed. Next one is the lateral overlapping, sidewise overlapping. Lateral and sidewise overlapping. Sidewise overlapping. First one, take nitrogen. If you take oxygen, oxygen means O2. How many bonds between oxygen and oxygen? 2 bonds. How many lone pairs? Here is 2 lone pairs are present because this one is the octet. Now how many pi bonds are present here? The pi bonds are 1 sigma bond is present, 1 pi bond is present. In double bond contain 1 sigma bond, 1 pi bond. Now first I am writing one of the oxygen electronic configuration. Here one of the oxygen configuration is 1s2, 2s2, 2p4. Here also taking another oxygen atom 1s2, 2s2, that is 2p4. Now 2p4 last electronic configuration I am writing 2p4. Now 2p4 means 1, 2, 3, 4. Next one, here also you can take 2p4 electronic configuration 1, 2, 3, 4. But off-filled orbitals with opposite spin only overlapping. Okay. Now I am taking oxygen. This one is the oxygen and here also oxygen. Here is sigma bond. This one is a sigma bond is formed between 2pz and 2pz. 2pz orbital and 2pz orbital to form sigma bond is formed. This is sigma bond. Next one, you can write the phi bond. We can write like this. Now pi bond write down. Here pi bond means how to formed the px, py, py of one oxygen atom, py of another oxygen atom. they are overlapping to form pi bond. This is the pi bond is formed. Example of oxygen. In this oxygen, okay, slowly we can remove this one. Here is mentioned, here to here. Now this one is pi bond is formed. This is called pi bond and sigma bond. In oxygen, I am taking one of the oxygen here. Here is another oxygen atom. The electronic configuration is 1s2, 2s2, 2p4. Here also 1s2, 2s2, 2p4. Next write 1, 2, 3, 4. This one 2p4 I am writing here. Here 2p4 means here 1, 2, 3, 4. Now off filled orbitals with opposite spin is overlapping. In between oxygen, how many sigma, how many phi? 1 sigma, 1 pi bond. That is 1 sigma bond between 2pz and 2pz. Because 2pz is the internuclear axis, because sigma bond is formed 2pz and 2pz. Here is the 2py and 2py to form pi bond is formed. This is the example of oxygen. If you take nitrogen, here I am taking nitrogen. In nitrogen and nitrogen, how many bonds are present? 3 bonds are present. First write the one of the nitrogen electronic configuration. Here also nitrogen 1s2, 2s2 and 2p3. Next one here 1s2, 2s2 and 2p3. One is the 1s2, nitrogen is 1s2, 2s2, 2p3. Why? The nitrogen atomic number is 7. Here also 7. Now write 2p3 electronic configuration. 2p3 means 1, 2, 3. Here also 2p3 is there. Here is what is the VBT? VBT means off filled orbitals with electrons of opposite spin, they are overlapping. Now this one overlapping, and this one overlapping, and this one is overlapping. Now how many pi bonds are present? How many pi bonds? 2 pi bonds are present. 1 sigma bond is present. 1 sigma bond and 2 pi bonds in a triple bond. Now px, py, px, they are overlapping to form pi bond, and py overlapping another pi bond, and pz and pz, 2pz, this is 2px, this is px, 2px, this is 2py, this is 2pz. Here also 2px and 2py and 2pz, because this one only we can writing 2px, x, y, z. Now we can write the orbital orientation. Here I am taking nitrogen, 1 nitrogen. Here also taking 1 nitrogen. One of the sigma bond is formed. Here is one of the sigma bond is present between 2pz and 2pz. Next one is one of the pi bonds. Here is another orbital, p orbital. In here also another p orbital. Now write what are the overlapping 2px. This one overlapping, and this one is overlapping. Now I am taking this one overlapping, and this one overlapping to form how many pi bonds? 1 pi bond, 1 pi bond. 2 pi bonds, 1 sigma bond. This is the representation of nitrogen molecule. This is the oxygen molecule. Please write down this. Very easy. In oxygen molecule I am taken. In oxygen and oxygen 2 bonds are present. One is sigma, another one is pi bond. Now I am taking, here is one of the oxygen 1s2, 2s2, 2p4. Here also 1s2, 2s2, 2p4. Now I am writing 2p4 representation. Here also 2p4. What is the VBT? Off filled orbitals with electrons of opposite spin. This one is the downward, this one is the upward. They are overlapping to form 1 sigma, 1 pi. If you take nitrogen also, here how many pi bonds are present? 2 pi bonds, 1 sigma bond. That's why represented the orbital representation of nitrogen, orbital representation of oxygen. Please note down this. If you work on inorganic chemistry means a daily wise revision of S block and P block, it's very very important. And even chemical bonding also, you have to concentrate dipole moments and MOT, molecular orbital theory, and next to lattice energy and Lewis dot structures, hybridization of molecule, you have to remember it. Please note down this. After difference between sigma bond and pi bond, we can discuss sigma bond and difference between sigma bond and pi bond. Sigma bond, write one sigma, here I am writing pi bond. Sigma bond is the extent of overlapping and pi bond is the less extent of overlapping. More extent, head to head overlapping means more extent of overlapping. Here is axial overlapping or head to head overlapping to form sigma bond. Here is head to head means more extent of overlapping. Lateral overlapping means this is a sidewise, like this sidewise overlapping means less extent of overlapping. This how to form pi bond, that is sidewise overlapping of orbitals, atomic orbitals overlapping or lateral overlapping. Next, which one is the stronger bond? Sigma bond is the stronger bond. The sigma bond is the stronger bond and pi bond is the weaker bond. Pi bond is a weaker bond or weak bond. Why weak bond? Less extent of overlapping. Here is more extent of overlapping. If large portion of extent of overlapping, head to head means more extent. That's why the strength is increases. Here is extent of overlapping increases. Extent of overlapping increases. Now bond strength is increases. When bond strength increases means bond energy increases but bond length decreases. Remember, extent of overlapping increases, bond strength increases, bond energy increases, bond length decreases. Now here is extent of overlapping is less. Extent of overlapping is less. Where the condition? Pi bond. And sigma bond, more extent of overlapping. Sigma bond formed alone. Sigma bond formed alone, but pi bond is not formed alone. Pi bond is not formed alone. Alone it is not possible. After sigma bond formation only pi bond is formed, not alone formation. It is very difficult. Here is sigma bond formed alone. In between two atoms, one sigma bond is present. One sigma bond is possible in between two atoms. For example, A and B, how many sigma bonds? One sigma bond. In between two atoms, one sigma bond is possible. In between two atoms, and two or three. One or two possible. If for example, if you take oxygen, two are the atoms. These are the oxygen atom. One pi bond, one sigma bond. Here is nitrogen and nitrogen. One sigma bond, two pi bonds, or one or two. In between two atoms, one or two possible, but in sigma bond in between two atoms, one sigma bond is formed. What are the points we discussed? The difference between sigma and pi. It is sigma bond is formed axial overlapping or head to head overlapping. Pi bond is formed sidewise overlapping. Next one is stronger bond. This one is weaker bond. What is the reason? Extent of overlapping increases, bond strength increases, bond energy increases, bond length decreases. Pi bond is not, extent of overlapping is less. If extent of overlapping is less means bond strength decreases. Bond energy decreases means bond length increases, because length in between, for example, these two atoms very far away, here is far away, means bond length increases. If length increases means energy decreases. What is bond energy? The amount of energy required to break the bond. Easily we are providing to break the bond. Now sigma bond formed alone and pi bond is not formed alone. In between two atom, one sigma bond is formed. In between two atom, one or two pi bonds are formed. Next one, sigma bond rotation is possible. Sigma bond rotation possible. Rotation possible. Next to pi bond restricted to rotation. Restricted rotation. Rotation is restricted because double bond and triple bond is not rotated. That's why these are the difference between sigma and pi bonds. And if you watch videos properly, you can understand whatever I taught in chemical bonding. The students and your life, you can challenge your goals and work hard. Everyone having that capability, you have to do hard work and day first onwards, and you can prepare timetables and work hard. You absorb pain, then only you will get the success. All the best, my dear Neet aspirants. Best of